right. All right, I told you guys I was going to be absent today, but look, I'm here. So I know this is kind of weird, and this is going to be a very low quality video, but I really wanted you guys to be exposed to what the lab process looks like for a titration. So you need your labs out. It's on page 21. I can show that to you, but everything's flipped. So yeah, so it's page 21, and we're going to be filling out some data on the backside. So basically, I'm going to do the lab. You guys are going to write down the data, and then you're going to crunch a bunch of numbers, and this lab's due by the end of class. Okay, so titration. We talked about this yesterday. The basic idea of a titration is that you have an unknown. Today, our unknown is this guy, vinegar. Okay, we know the active ingredient is acetic acid. Wow, my hand really looks big. Okay, focus. So the active ingredient in vinegar is acetic acid. We want to know what's the molarity of acetic acid in the solution. Is it like 10 molar, 5 molar, 0.1 molar? So that's what we're going to find out. We're going to use a titration to do it. So this is our unknown, okay? And the idea is that we're going to take an acid and we're going to react it with a base. The acid in this case is our unknown. The base is going to be our known. Our base is sodium hydroxide, okay? So if it's our known, what do we know about it? Okay, well the base, it says here on the label, is 0.500 molar. So I know the concentration of the base. I need you guys to write that down on your lab. So on the back side, the 1, 2, second entry, it says concentration of NaOH. I want you guys to write down 0.500 big M molar. Okay, I know that's backwards, but you guys get the idea. 0.500 molar. Okay? All right, now, to do a titration, we get to use a really fancy piece of equipment called a burette. Okay, it's spelled like one of those little French hats, like a beret, but it's a burette. Let me show it to you. Okay? Sorry if you're getting seasick. Okay? So here's the burette. Starts down here and it goes whoop, 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 whoop. So it's really, 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 really tall piece of glassware. Okay? And kind of like a eudiometer, do you guys remember us using that? It has volume markings on it, so you can do really accurate volume measurements. Okay, so this is a burette. The burette is for the known solution. So in that case, that's our sodium hydroxide. Now, I've already rinsed the burette with distilled water to make sure it's clean. Now what I'm going to do is I'm just going to run a little bit of the base through. Okay, and the known molarity, the known solution, we sometimes call it the titrant, okay? And I'm just going to run it through the bottom. I'm kind of like coating the sides with sodium hydroxide solution to get rid of the distilled water, okay? Because if the distilled water stays there, then that's going to dilute whatever's in there, okay? So now the sides are coated with the sodium hydroxide, okay? Now, that's actually the second time I've done it, okay? So now I'm going to fill the whole burette up with sodium hydroxide. I know you guys can't see the top, and let me just tell you, if you are a tall person, uh-oh, I gotta close this. If you are a tall person, you were born to do titrations. I am not a tall person, so it's a bit of a struggle. Okay. Really don't have to fill it all the way to the top, okay? It doesn't really matter because I'm going to record wherever it started. So if you guys take a look, I get there at the top, whoops, whoops, whoops. That's where our level is, okay? All right, so our burette is ready to go. I'm going to record, actually I'm just going to run a little bit through so there's no air bubbles, okay? And then I'm going to record the initial burette reading, okay? Now something kind of cool that you can do, try to move this back so you guys can see. Sorry about that. Okay, is that I have this piece of paper with black on the back, and it makes it a lot easier to read. Okay, so I'm up here reading it. It doesn't much matter, but it's right around, if I get eye level, it's right around exactly 7.00 milliliters. So again, on your lab, it says initial burette reading. I want you guys to write 7.00 milliliters. Okay, with the burette, that's where our NaOH solution volume is starting. Okay? All right, we are all set with the NaOH. Now, this is called the Erlenmeyer flask. Let me say that again, Erlenmeyer flask. Okay, and this is for what we're titrating. This is for our unknown. Okay, so I'm going to take some vinegar. Now the lab says use about 15 milliliters. It does not really matter how much you use. The more acid you use, the more base you're going to need to titrate it. Okay? What matters is that you do record that volume very accurately. Okay? So you guys can roughly see where the volume line is. So I'm going to say that looks like exactly, I guess, 14.50. So again, on your lab. Woohoo! There's your lab. The first data entry says amount of C2H3O2 solution. Okay, and again, that was roughly, or exactly, I should say, 14.50 milliliters. So now you guys got the first three pieces of data collected. All right, so I'm going to go ahead and pour this in my Erlenmeyer flask. Okay. And you know what? The great thing is now that the acetic acid is in there, if I add a little distilled water on the sides, is that going to make my data wrong? No, because you know what? As long as the moles of acetic acid are still in there, adding a little water isn't going to change that. The moles are still in there. So a little distilled water helps get some of it off the sides. Alright, this is absolutely so important. Talked about this yesterday. To do a titration, you have to somehow make it visual. You have to make it clear when you've added enough base to neutralize the acid. You need an indicator. Yesterday we used that really fun one with all the colors, the universal indicator. Okay, it went the colors of the rainbow. Today we're using a much more classical indicator. It's labeled with this P, except it's backwards. But it's called phenolphthalein. Okay, now phenolphthalein is kind of really clear, or really easy to work with because it's colorless in acidic or neutral conditions, and it's this lovely shade of pink in basic conditions. So I'm going to add a couple drops to the indicator. Okay, and notice, you know what? It's still colorless because this is an acidic solution. So again, it's colorless in acidic or neutral conditions, and then this lovely shade of pink, okay, in basic conditions. Okay, well, you know what? We are ready to titrate, okay? So the basic idea is I'm going to add enough base to just neutralize the acid, okay? I'm going to get a little closer so you guys can see, okay? Basically, I'm going to add that NaOH. Okay, now can you guys, if you look really closely, can you see a little bit of that pink color? Might help if I put a white background up against it somehow. That doesn't really help, does it? I need another hand. Try that. See? Now you guys can see that pink, alright? But you know what? That pink does not last, okay? When that pink starts to linger a little bit, I'm going to slow down because the idea is that when that base reacts with the acid, it goes back to clear because there's plenty of acid still. But when that pink starts to linger, that means the base up here is having trouble finding acid. That means we're getting close to what's called the equivalence point. Okay, so I'm going to keep adding. Going to wait till that pink color kind of sticks around. Notice how I'm a good swirler. Now, every once in a while, in case some of those acetic acid particles got on the sides, I'm going to go ahead and rinse it. Okay, so a little distilled water won't hurt anything. Keep going, keep going. I'm sorry you guys have to watch this. I know this is not a very professional video. Okay, we're getting kind of close here. Sticking around. That pink color is just not disappearing as fast, so I'm slowing down. Sorry, I think my hands are sort of in the way. Hi, me again. It's like a weird light shining. Okay, why is there a weird light shining? I don't know why. Is that better? Maybe? Whoa, that is kind of nice. Okay, so we're getting closer, getting closer. Now, if you guys were really doing this titration, one trial is never enough. First trial is kind of like practice. You usually totally mess it up. Okay, and then when you do the second and third trial, you get a lot better data. So I'm going to start slowing down. Ooh, we're getting close. Now, those of you guys that are going into AP Chem, you will do like 1,000,000 titrations. You will get super good at titrations. And even in biology, they have a couple, AP Bio, they have a couple titrations. Whoa. Guys, see how that pink is sticking around? Whoa, man alive. Okay, now that is most certainly pink. Okay, now you could probably say that I went over the equivalence point just a little bit. Because really what you're going for is like the lightest shade of pink ever, okay? So basically, I added enough base to neutralize the acid, and then I just went a pinch over. So that's why the whole solution went to pink, because phenolphthalein is pink in the presence of base. All right, well, you guys, that gives you an idea what a titration is all about. Okay, the final burette reading, okay? Take this guy and move it. I know you guys are getting seasick right now. Let's see if I can find it. You guys can see where the level is. Of course, you can't read it. Okay, it's jiggly, but I will read it for you. Okay, it's coming in at about, you guys can write down 31.40. Okay, so again, on your lab, this would be the 1, 2, 3, 4th data entry, 31.40 milliliters. Okay, now, that's what I was saying about the NaOH. Doesn't really matter where you start or where you end. What you're concerned about is the difference. So the initial burette reading was 7 milliliters. The final burette reading was 31.40 milliliters. Do you guys suppose you could calculate the amount of NaOH you used? So you guys using your savvy math skills, you should be able to figure out the amount of NaOH used. Okay? We do not have to worry about the average, so you don't have to do that part. Okay, wow! Guess what? Now it's up to you. Okay, you guys have this data. You guys can calculate. It's going to be just like the calculations we did with the titration practice in class yesterday. And guess what? That's it. Woo! I will see you guys tomorrow on Friday. Don't forget you have a quiz. Make sure you guys study. And if you have any questions about this, you can certainly ask. All right, thank you for listening. Woo! That's my hand. Bye.